Hi everyone and welcome to my Go course. In this video we're going to talk about integer data types. So in previous video we had an overview about the different data types in Golang, and today we're going to talk more in details about the integer data types. So Golang provides um, two categories of integer data types, which are signed integers, like for example int 8, int 16, int 32, and so on, and unsigned integers, like you int 8, you int 16, and so on. What is the difference between them is that for the integer type, 1 bit of its size is used to store the sign of the number, and the rest of the bits are used to store the absolute value of the number. I came across this picture which explains this on an example. And for instance, we're using here an 16 bits or 2 bytes integer number. So here is the example of an unsigned int, for instance, uint 16. And as you see, all of the 16 bits are used to store the absolute value of the number. And here is an example of int signed integer data type. And as you see, 1 bit is used to store the sign, whether it's positive or negative value, and the rest of the bits are used to store the actual value. So the actual value is the size is limited by 15 bits. And what is the consequence of this is that, for example, if you define a variable of an integer 8 data types, you have only 7 bits. You're limited by 7 bits of information. So if I want to assign it a big value, for example, like 255, the compiler will complain because this value overflows the actual range for this data type. And if I try to assign it like this, it works. And the same works if I use an integer 16 data type and I assign it a negative value, not too big. So it works both with positive and negative values. But as you might have noticed, if I type, for example, a very big value which overflows this particular data type size, then my compiler or my IDE complains. So um, what are the restrictions? What are the limits? What are the ranges for every data type? You can notice that every data type name has this number 8, 16, 32, here the same. And it basically means the amount of bytes, amount of bits used to store the number. Because I showed in this example that for unsigned integer, we use all of the bits to store the actual value, and for signed, we use 1 bit to store the sign of the number, and the rest is for the actual value. And this picture shows us the actual ranges for every data type. So for int 8, which has the size 1 byte, 8 bits, 1 byte, the range is from minus 28 to 127, sorry, from minus 128 to 127. It's because 0 is considered as a positive value. That's why it's included in the range. And these are the ranges for unsigned integers. As you might have noticed, the range for unsigned integer is always twice bigger um, than the range for the corresponding signed integer type. It's because, as I mentioned previously, 1 bit of signed integer data type is used for storing the sign of the number. So let's move on. And I showed you these particular data types, integer data types, and unsigned integer data types as well. And you might have noticed that there is one particular data type int and another one uint, which doesn't specify the precision, the size in bits, and actually its size depends on the processor you're using and the operating system. For example, for my processor, architecture, it's gonna be 32 bits, um, but in your case it may be even 64 and so on. So that's why if you need to know the exact precision, or if your requirements is to know the exact precision of the integer numbers, I recommend you using one of these um, integer data types. And the same is applicable actually for uint. For my operating system, for my processor architecture, it has 32 bits of size. So all of these data types are just um, syntactic sugar, not the syntactic sugar, but the way to work with them. But underneath, for the operating system, for the processor, these are just all binary values. And let's talk about, for example, the integer literals. So in the previous videos, I showed you when declaring a variable I, for example, I would use an integer literal, for example, 356. But actually, depending on the form of the number, I can use also a binary representation or a hexadecimal representation, doesn't matter. For example, um, this is, for instance, this is an example of the binary representation of a number, and um, this is an example of an octal representation of an integer number, and this is an example of a hexadecimal representation of a number. So you can use whichever is suitable for you, or whichever requirements do you have, depending on the type of application you write. But you should know that all of the integers number are basically represented um, as sequence of bits, 0 and ones, on the processor level, but it doesn't stop you from using different kinds of literals, whichever is suitable for you, whichever is convenient for you. And also you should know that the FEMT package has the printf function, um, and using this function you can actually print out the number in whichever format you would like to use. For example, using the uh, decimal template, you can print it in like a usual decimal format. By using the B template, you will print it in the binary format, um, octal format, and hexadecimal format. So let's say, for example, I would like to print I in every of these formats. Um, I'll just comment these variables and run this code. And as you see, we've just printed out the value of this variable in different formats. With values, with literals and variables of integer data types, you can perform any arithmetic operations by using the arithmetic operators. So Go provides several, for example, for addition, subtraction, multiplication, and deletion. You can use these operations to perform the arithmetic operations on integer values. The only restriction is that any arithmetic operation performed on integer variables will result into an integer. So let's say if you have variable a and variable b, both are integers, for example 10 and minus 45. If you add them, the result of this operation will be also an integer, which is fine because, as we know, the sum of two integers is always an integer. But what will happen if we decide to divide a by b? The result of this operation will be still be an integer, and this is not the problem, but this is a kind of restriction because in this way we'll lose the remainder of this operation. And Go also provides a modular operator. For example, if we say a, if we want to know the remainder of the division a by b, we can use the modular operator, and this will result also into an integer, which will represent the remainder of this division. There is one more important point to mention is that even though all of these different data types are integers, the precision matters. And you cannot have two variables of both of integer data type, but with different precision. And you cannot perform a arithmetic operation on both of them. For example, let's say we have an integer 16. Let's give it an integer 16 data type, and a second variable will be of integer 32 data type. And let's say we have a variable in which will be a result of the sum of addition of I16 and I32 variables. And we'll see that the compiler will complain because this operation is invalid due to mismatch of the data types, because first one is int16 and the second one is int32, and an overflow can happen. That's why Go prevents you from performing this operation. And if you remember previously, I said that for my processor architecture, this data type int has the precision of 32 bytes. But Go will still prevent me from using this kind of variable. For example, let's say I32 is an integer, and another I, let's call it just I. It will be data type integer, and I32 will have data type int32. So Go will also prevent me from using this kind of code. Even though both variables, both data types have the same precision of 32 bits for my processor architecture, but um, this is implicit, and Go doesn't allow me to do this explicitly. So for this purpose, I should actually convert one of these variables by using this kind of syntax, the data type and braces, to convert this particular variable into int32. And the same you can do also with other data types if you need to perform arithmetic operations. Golang also allows you to perform bitwise operators on integer data types. Let's demonstrate this by printing something into the standard output of my machine. I'll delete this code. And so the bitwise operators, like AND or XOR, left and right shift, you can use them in the same way in Golang you would use in other programming languages. So the bitwise operators are, for example, AND, bitwise OR, um, XOR, XOR, XOR. There is also left shift and right shift. There is also another operator you may come across, which is bit clear or it's also called AND not. So you can use any of those operators to perform bitwise operations on your integer numbers. For example, let's say we would like to have the bitwise AND of two integer values, and let's represent them in the binary format. That's why I'm using this binary template, and I would like to define these numbers by using the binary literal. So that I have this kind of code. And because in this way it's pretty easy to know the result, because 0 and 0 is 0, and 1 and 0 is 0, and 1 and 1 is 1. So the result, I guess, should be 0, 0, 1, 0. Let's run this code to see what will happen. And I forgot to put here the break line. I'll put it. Actually, I'll delete this statement. We don't need it anymore. And I'll run the code once again. And I'll command this variable. Okay, and run the code once again. And we see 11 and 10. We forgot to write the result. Is equal to binary. Let's copy these two numbers and just use the AND operator. I'll clear the console and run the code once again. And we see 11 and 10, or better to say 1, 1 and 1, 0 is equal to 1, 0. Right. So in this way you can use actually any bitwise operator. What we won't cover in this video is usage of unary operators. It's not really common. They are not really commonly used, but I'll explain them shortly. So these operators you see here are basically they can be used as binary operators. It means for binary operators, you always have two operands, left and right. For example, in case of the sum of a and b, a plus b, plus is the operator, and a and b are operands, left and right operands. And the result of this operation is sum of a and b, for example. And for instance, unary operators can be used only with one operand. They require only one operand. And there are only two unary operators, plus and minus, and plus basically does nothing. It doesn't change the value, doesn't change the operand, and minus, on the other hand, inverts the sign of the operand. And that's why the result of this unary operation, for example, minus, let's imagine you have a variable a with an int value or even unsigned int value. The result of this operation will be an integer value, because only integer values, signed integer values, data types can hold positive and negative data. This is pretty much it regarding integer data types in Go. Please hit the like button if you like the video and subscribe to the channel for updates. And thank you for watching. I'll see you in the next one.